From last video, I introduced what acoustic emission is, and there are two kinds of AE signals: burst AE signals and continuous AE signals. The main difference between burst signals and continuous signals is that burst signals can be separated by time while continuous signals cannot. In most practical and engineering applications, the method of extracting waveform characteristics to obtain AE parameters is often used to analyze acoustic emission signals. In this video, I will introduce the feature extracted parameters of the AE signals. A burst AE waveform is used as an example. Threshold. A threshold is the input level to trigger the acquisition and recording of the burst AE signals. Hit. When the AE signal exceeds the threshold, that is defined as one hit. The burst acoustic emission signal's characteristic parameters are extracted from a single hit. Amplitude. The amplitude of AE signal is the peak amplitude of the waveform. It reflects the strength or intensity of the acoustic waves generated by the source event. Larger amplitudes often indicate more significant or more energetic events. It is usually presented in dB. Duration. The duration of the AE signal is the length of time starting from the signal exceeding the threshold to falling below the threshold. It provides some insights into the temporal characteristics of the source event. Rise time. The rise time is the time taken for the AE signal from the threshold to reach its peak amplitude. This time parameters can provide information about the dynamics of the source event. Energy. The energy of the AE signal is a measure of the energy released during the acoustic emission event. It is often calculated by integrating the signal amplitude over time. Counts. The number of ringing exceeding the threshold in one hit. The counts roughly reflect information about the intensity and frequency of the signals. RMS. A statistical measure defined as the root mean square of the AE signals. It is usually used for continuous AE signals and not affected by thresholds. RMS is usually measured on a linear scale and reported in volts. ASL. A statistical measure defined as the average of the AE signal amplitude. Because the ASL considers the AE amplitude in a logarithmic scale, it must be reported in dB units. It is usually used for continuous AE signals. Understanding and analyzing these features allows inspectors to interpret AE signals, identify the type of events occurring within a material or structure, and assess the condition and integrity of the material in real time or through post-event analysis.